Yeah, we're going to look at the geometric sequence formulas, specifically from the Algebra 1 ELC sheets, these two right here. Spend most of our time on the explicit one. Okay, so I'm going to write this formula down and show you my board here in a minute. A sub n is equal to a sub 1 times r raised to the n minus 1 power. So what does all that mean for a problem like, say, number 1 here, where if you read it, it says, determine if this sequence is geometric. If it is, find the common ratio in the explicit formula. Geometric simply means you're multiplying over and over by the same thing. To see if you are geometric or not, you want to just observe to see if you're doing that. And you can easily tell by dividing any term by its previous term and see if it's consistent. In other words, on number 1, 18 divided by 3 we know is 6. 108 divided by 18 may not be as obvious, but that is also 6. You can confirm that on any calculator. 648 divided by 108 is also 6. So this is in fact a geometric sequence. Now to write the explicit formula, I have the formula written down from the formula page here that it was 3, 18, 108, 648. Okay? So when we write down the formula, we generally want to leave this n alone. N is just a counter. It just says, hey, give me any position in the sequence, and I'll tell you what number's in that position. So we're not going to worry about n right here. A sub n is a sub n. A sub 1 would be the first term. Very easy. It's just a 3. And the common ratio is what you multiply by. So if you know it's geometric, you can just divide any number by the previous number, which I guess the easiest would be the second divided by the first, which often you can tell by looking at it what that is. Sometimes you may need decimals. And again, we're going to leave n alone. So this is the explicit formula. What this does for us is, again, it allows us to build the sequence or to tell any number in any position of the sequence by plugging that position in. In other words, the third number we can see is 108. If I were to plug a 3 in this position, 3 times 6 raised to the 3 minus 1 power, you'll see that produces 108. And that's what the explicit formula does. But for this worksheet, all you're doing here is determining a sub 1, determining r, and putting those numbers into the correct position. Keep in mind that there's the potential that some of these may not be geometric. So looking at another example, say number, we'll just look at one that alternates. How about number 6? Okay, on 6, same question, 3, negative 6, 12, negative 24. Okay, and the questions are the same. Is this geometric? Here it's actually a little easier to tell. You're clearly multiplying by 2 if you disregard the sign, but since the sign is going back and forth, you're multiplying by negative 2. That's pretty easy to tell. So using the same formula from above, a sub n is equal to a sub 1 times r to the n minus 1. Again, we're going to leave n alone. A sub 1 will be 3 for the second time, just coincidentally. As we discussed, r is negative 2. You're going to want to put that in parentheses because of the negative to show that we're multiplying by the negative there. And this is your explicit formula. Okay, so quite simple there. Just determine a sub 1, determine r. Now later on in the worksheet, it asks you to, it actually gives you the formula and wants you to find the first 5 terms. I'll just take, say, 22 as an example. 3 times negative 3 to the n minus 1. What are the first 5 terms? Just like that. Okay. To find the first term, well, you already know the first term is 3 because that's what this number is the first term. So you don't have to think about that. And since we know that the common ratio here is negative 3, I can just multiply by negative 3. 3 times negative 3 is negative 9. Negative 9 times negative 3 is positive 27. Notice it's going back and forth. And use Desmos as needed. 27 times negative 3 is negative 81. And negative 81 times negative 3 is 243. Okay, I would do as much as I could without Desmos to just sharpen my understanding. But again, you start with this number, and you keep multiplying over and over by this number here. Lastly, let's look at an explicit or a recursive. Okay. We'll go to the formula page here. Recursive, as you can see here, says a sub n is equal to r times a sub n minus 1. And that n minus 1 is a clue here that it's recursive. When you see n minus 1 as a subscript, it means the previous term. So a sub n is the current term. A sub n minus 1 is the previous term. So it's just saying to take each number and multiply it by, to get from one term to the next, multiply by the common ratio. So you'll see this problem 31 here is in that similar fashion. Okay, a sub n is equal to a sub n minus 1 times 3. Now the recursive formula is not as powerful as the explicit formula. I can't tell you immediately what the 50th term is. I would have to literally multiply 50 times. But what it does do is tell you instructions as to how to get from one term to the next. To be able to get going, you need to know a term. So it's going to give you the first term here. As you can see, a sub 1 is negative 2. So let's go to our board here and figure out the terms after that. It's just understanding what this means, understanding that this means previous term is key here. All right, so my first term is negative 2, and to get to any term, you multiply the previous term by 3. So negative 2 times 3 is 6. Negative 6 times 3 is negative 18. Negative 18 times 3 is negative 54. Negative 54 times 3 is negative 162, I believe. Again, you can use Desmos as needed. Later on, we'll show some tricks on Desmos, but I won't immediately show you Desmos because you need to understand the concepts yourself before going there.